get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, good morning, good evening, good afternoon, wherever you are in the world. This is the Ask an OpenShift Expert live stream. I'm Jonny Rickard. You may have noticed that Andrew is not with us today. He's off saving the world again. This is going to be a common occurrence with our OpenShift superhero, Sully, who is always out doing all kinds of crazy stuff. So he hopefully will be back with us next week. But this week's episode is migrating VMware workloads into OpenShift Virtualization. And this is a two-part series that we're putting together. And this week we're going to talk about the how and the why you do the OpenShift virtual, or why you would migrate your workloads from VMware into OpenShift Virtualization. We're going to do a couple of demos, and then we'll get everything kind of set up and prepped for next week. Before I get started, I'm going to do quick intros. So Machi, let's start with you.
Sure. Hey, my name is Machi. I'm a OpenShift specialist here at Red Hat, and after hours, I'm a network enthusiast.
Awesome. Jared.
So, Jared Burke, I am a managing architect in our consulting division here in North America. Specialize in OpenShift. I've been with Red Hat for 15 plus years, and you're
Red Hat senior citizen.
I am. I've learned our portfolio and try to share the knowledge with the world.
Nice. All right, Atta, how you doing?
Yep, I'm also OpenShift architect, and my focus is on virtualization part of the OpenShift.
Okay, awesome. And then Jonathan, welcome back.
Yeah, thank you. I'm Jonathan, product marketing at Red Hat. So, and I'm catching up to Jared. I'm, I think, 12 or 13 years here. So,
nice.
On point.
I'm right behind you. I'll be here 10 years in July. So, we're the old guys now, huh?
Yeah. It says something about the company when people stay here a long time.
I agree. So before we get started, I just wanted to do a quick recap. I was in KubeCon Amsterdam last week. It was awesome. One of the big things that I think was like prevalent across all of the vendors was like there's a lot of observability. Obviously, AI is a big factor in a lot of things, but like there's a lot of observability tools out there. Products like Crossplane and Upbound, they're doing some big things with infrastructure management, especially managing infrastructure at the API level, and where you can manage everything as a Kubernetes resource is really what I'm trying to say. And I think it's pretty cool. IBM's KubeCon had a pretty good pavilion, and pretty cool show that they're putting on. So we're gonna try and get those guys on later in the summer, or later in the spring, maybe early summer. But yeah, hopefully have them come on and do a demo again and talk about everything that they're doing. Right before KubeCon, there was a release for the cluster observability operator. One of the big things that are coming out in this is that they are tech preview for the Percy's database, or the Percy's dashboards. And if you remember our stream with Christian Stark, where he was showing off some of the ACM observability things that he was doing, that was all built with the Percy's dashboards. So Grafana is still a thing, but Percy's it's the new hotness, and that's where the dashboards are going, and they're really slick and pretty simple to manage. Lots of other things going on with that, but that was the big things that were coming out. So with that said, I guess, or actually, I'll kick it over to you, Jonathan. Yeah, let's do some slides, and then we'll kick into the demos.
Okay.
Bam, here we go.
Okay, slides are good.
Yep.
Okay. So what is OpenShift Virtualization? It is essentially a feature of OpenShift that will host virtual machines. So let's distinguish. So OpenShift is a container platform, and virtual machines are not containers, right? So containers reduce the hypervisor layer out of the stack, as you see in this diagram, and you get a slimmer, smaller footprint for running your apps. But we also can host virtual machines, as I said. So OpenShift will host VMs, even though it is a container platform. Okay, so you can put those virtual machines into containers. And in KVM, which is the hypervisor used by OpenShift, kind of equivalent to VMware's ESXi, it is the hypervisor layer, and it provides compute network and storage to a VM in OpenShift, just like you would in VMware or any other Virt platform. So what is OpenShift Virt then? It allows you to run VMs in containers, you manage them as pods, it's on the KVM hypervisor, and it uses Kubernetes to orchestrate and do everything with the VM, just like you would with a container. So it's the same tool set and the same experience and management experience you use for containers as you would for VMs. Again, we use a KVM, which is the hypervisor layer built into the Linux kernel. And it's been part of RHEL for more than 10 years, our Red Hat Enterprise Linux, and it uses all the goodness of RHEL and virtualization to enable that. Okay, so virtual machines in a container world, it provides that abstraction, and it means that once the customer has moved their VM into OpenShift, they could potentially containerize that application and run it as a container. But if not, it keeps all the traditional Kubernetes paradigms. So you have a container network interface, you have container storage interface, custom resource definitions, and you run that VM just as you would run a container. And therefore, they can be run together. So you can connect them to the same software-defined network. You can use the same Kubernetes methods for networking or a service mesh or a pipeline, and connect to application pods. So just as you run a VM in a container in OpenShift, so can you run a VM. And this allows you to use the same tool set, the same CLI, the same graphic user interface, whatever methods you want to manage your containers, you can use the same to manage your VM. So what does that mean? If you're currently on another virtualization platform, perhaps VMware, and you're seeing some increasing costs with some new licensing that has come up, or you're being forced to migrate to vCloud Foundation, and you're looking for alternatives, so you can migrate your VMs to OpenShift Virtualization. You can start with OpenShift Virtualization Engine and just run VMs, and then afterwards you can up to OpenShift itself, have a full OpenShift license subscription, and do both containers and VMs. You can have the same developer environment for containers and VMs. And even after that, you can move on to OpenShift AI and use AIML, or it's all on the same platform. You don't need to re-platform, you don't need to re-migrate. Once your VMs are in OpenShift, you get all the goodness of the OpenShift container platform and the OpenShift AI. So go ahead and bring your VMs into OpenShift and learn some of the concepts that are might be new to you, but not really that hard. Once you've been a seasoned administrator of another platform, such as VMware, it won't be such a big uplift to learn OpenShift. So with that, let me hand it over to the demo experts. Thank you.
Yeah, and one thing, like if you've seen the OpenShift virtualization console and the OpenShift UI, that team has done so well to like make it. It's the interface is very familiar, right? If you've used VMware and you're used to like having the tree span and stuff like that for your cluster views and your virtual machines and stuff like that, like they've done an excellent job of making sure that it's not an identical parity to from one to the other, but just that feel of being able to collapse and expand your clusters and data centers and things like that. It makes your workflow a lot nicer, or a lot easier if you're coming from VMware into OpenShift virtualization. It's come a long way. It's really neat.
So good morning, team. My name is Ata Mufti, and I'll be doing the demo today. Let me go ahead and share my screen. Okay. So in today's demo, we'll be creating a VM, attach it to the network, then add more storage to it, and then we'll add another secondary network with the layer 2 connectivity. So let me go step by step, and this is where my URL for OpenShift console, I'll go ahead and log in using my LDAP credentials. And this is a live demo, so
Anything that can go wrong will go wrong.
will go wrong.
That's
Yeah.
right.
Yep. So once I'm logged in to my OpenShift console, I'll go to the virtualization, then virtual machine section of it. So pretty straightforward. Everything is organized as project. So project is how we isolate or scope various tenants or resource pools like VMware. So I'll go ahead and create a virtual machine using one of the existing templates that are always part of the OpenShift. Here on the project, I've created a project for this demo, Ask an Expert. So I'll select my project and then I'll create a RHEL 9 VM for this demo purposes. So click on my RHEL 9 template. I can name something RHEL 9 demo like VM name. Then I'll go ahead and customize this virtual machine with few options that I want to use or a few features in the network interfaces. So by default, it gets you on the pod network, but in our use case, we want to have our custom network. I'll go ahead and remove the pod network and attach it to the VLAN that I already have trunked to my nodes, and then created a port group or network attachment group in my OpenShift environment. So it is VLAN 2104 that I'll be using for this demo purposes. I'll go ahead and save this configuration. Then I'll go to the script section of my virtual machine definition. I also do a couple of modifications here. Cloud user is the default user for the RHEL 9. I'll go ahead and change the password to something that is easier for this demo purposes. Of course, you can use the default password as well. I'll click add network data, and this is where I'll define the static IP address for the network interface that I just added to my VM definition. So let's see, I want to name it as ETH0, all GUI operations, just like VMware. I'll enter an unused IP address that I'll be using for this demo, and it's /CIDR length and the gateway address. So here it is. I modified the password in script section to something that is easier. I use the word Red Hat to make it simpler. And then in the add network data, I defined my Ethernet adapter name, the CIDR length, and also the gateway address. Hit apply. And I'll also add the SSH key so that I can SSH to my system. So I already have my SSH key added to this OpenShift cluster. I just need to pick that one in, or you can, click add new and add your own SSH key. Hit save. At this point, I'm good to create a virtual machine. I'll hit create virtual machine. It will be cloning the template and converting into the virtual machine and bringing it online. If I want to see the progress, I'll open the web console, connect to the web console and see what is going on. Oh, it's already there. So it done with the BIOS process, loading the kernel module, and looks like the VM should be up and ready in a few seconds. Oh, it's already there. So let's log in using the credentials that I put in my cloud init file, cloud user, and the simple password I used. So let's see what IP address is got. Look at that, same IP address that we defined in cloud init configuration. Now let's verify the external connectivity. I'll ping the gateway first. It can ping gateway, that is good. Let's try to ping a Google address. Here it can ping Google as well. So I'm a Windows guy. I'll try to do SSH to this VM from my Windows terminal. Here's my Windows command prompt, SSH-I, and then I'll have my key definition and SSH to this IP address, 172.22.4.242. Yes, and here I am. I am inside my VM that I just created. IPA, I can see the IP address. Again, I can ping an external address. So here we are. Task 1 is done. The VM is created from a template. It is on the network and it can ping the gateway and it can ping the Google. Let's move on to the second task of this demo.
Hey, Atta, real quick before you move on too far. One of the questions, I'm not going to say this handle, but it is funny. If you attach your VM to a VLAN, don't you just get rid of the whole networking paradigm in OpenShift, bypassing everything from the network policies to ingress?
Yes. Yep.
Yeah, you can still use multi-network policy for that kind of a network attachment, by the way. You bypass most of the OVN networking stack, but by using the particular network attachment definition that Atta is demonstrating here, he still has the option of using the multi-network policy CRD for further micro-segmentation of traffic that this VM is either receiving or sending inbound.
Gotcha.
Or
Yep. So like in VM world, we can enforce DFW type of policies through network policies if we want to control ingress and egress to this VM.
Awesome. And then the next question is, and this is more, it sounds like it's more of an opinion question, is doesn't it get, is it not mega annoying to manage the VMs next to containers?
No, it's pretty straightforward. And it works similar way like we used to do in the VM world.
Okay, awesome. Cool. I'll let you know if there's any more questions. Thank you.
Yeah, I'll add one more thing to that real quick. In the real world, it doesn't always happen to be in the same platform. A lot of times you'll see that for various reasons, you actually separate VM clusters from container clusters. Sometimes you'll even separate them out separate for like Windows versus Linux for various reasons. So, real world use cases, yes, you will see mixed use clusters where you see AI containers and VMs in there as well, but you also see segregated or specific clusters as well. So just depends really on your use case. But as far as managing them, that's the nice thing about they all become pods. So you do get to manage VMs traditionally, and there are a lot of similarities, but there are also a lot of similarities to the container world as well.
Yep. So many of our customers, they're using both ways. Some have dedicated clusters for virtualization and containers, and some are mixing in same cluster. It really depends on the environment and your requirement.
Absolutely.
Okay.
Yeah, awesome.
Okay, so next task is how to add storage to this VM. So I'm SSH to the VM. I'll look at what storage it has. So currently the default template comes only with 30 gig storage. Now I have a requirement to add another disk to this VM. So pretty straightforward. I'll move this window and go back to my OpenShift console. Back to OpenShift console, back to my VM definition, and again, go to the configuration section. Now my goal is to have an additional disk of X size attached to this VM. So go to configuration, there is a storage section to it. I'll hit add and add an empty disk. Let's name it as data. Name of the disk, I'll make size as 19 gig. It could be anything. Virtio is the interface, and then I'll select the storage class virtualization, which offer better performance for the virtualization disk. So define my name of the disk, size, storage class, hit save. So this is pretty much hot add disk to the VM, just like VMware world. It will take a minute before it scan the disk, the guest OS scan the disk, and it is available. Let me go ahead and write lsblk again to my system. Not yet, so give it another few seconds and it should show up. Looks like it's still scanning.
Good.
Here we are, 19 gig disk is added. So it took few seconds before it rescanned the storage, and then the guest was scanned it and added it to its configuration. So here we are, disk of 19 gig is available, ready to be consumed by the OS. We can format it, put partition table on it, and use it for whatever purposes we want. Okay, so task 2 is done. We have now more storage for the VM. let's move on to the third task. So our third task for today is adding another network to the VM. So network team, a typical situation in any organization, our network team has trunk the VLAN to the physical hypervisor, or in this case, OpenShift nodes. Now, being a virtualization admin, my job is to make this VLAN available to be used for the virtual machine that I just created. So in this case, I have to place some network configuration policies to add that VLAN. I'll go to the networking tab of my OpenShift console and then go to node network configuration policy. So node network configuration policy is where we manage or create our bindings for the bridge and various VLANs or networks that should be part of that bridge. So I'll open that multiple bridge network node network configuration policy, look at the YAML of it. And if we look at the YAML, I have already created definitions for some other VLANs that are part of this cluster, VLAN 2103 to VLAN 2106, and VLAN 2104 is the VLAN that we just used to demonstrate the primary network of this VM. So now let's assume that there's another network that need to be created, a backup network, VLAN 2109. So in order to create this definition, pretty easy, I'll write these 3 lines. I'm just going to copy it instead of typing in the demo. So same bridge name and local net name, I'll make it VLAN 2109. That is just the definition of my local network. Hit save. At this point, it is creating a bridge binding for my BR1-VLAN 2109 definition. Hit save. If I go to node network policies, I can see the progress it is applying to all of my 4 nodes that are part of this cluster. As we see, 3 were done, all done. It means that that bridge definition is applied to all those 4 nodes. My next step is to create the port group or node network attachment definition with that VLAN tag that I defined in my YAML file right here for VLAN 2109. So I'll go to node attachment definition. Scope is only this project, so it will be available for this project only. And if I want to make it available for all the projects or all the namespaces, I just put it in the default. For this demo purposes, it is fine to have it in my personal or Ask an Expert project. So create node network definition. Name, I can write any name or VLAN 2109. Network type, it's the OVN bridge, of course, OVN Kubernetes secondary local net. Bridge mapping, that would be the same name that I defined in my node network configuration, BR1-VLAN 2109. MTU, if I have a requirement of using jumbo frame, then I will write my MTU size with whatever I want to use. 9000 is pretty standard. And this is the key part of it, VLAN 2109, the tag I want to use for the VLAN. So 2 critical decisions here, VLAN tag that I want to use and the bridge mapping, the name I use in my node network configuration. Hit save or create. My node attachment definition or port group is created and ready to be attached with my virtual machine. I'll go back to virtual machine, again to my RHEL9 demo VM, go to the configuration section and then network section. So for this network, VLAN 2109, I have enabled DHCP. It has only layer 2 connectivity with no gateway. Think of it as a backup network that any organization have typical requirement. I will add this network interface to my existing VM that we just created for this demo purposes. So add network interface, I'll name it as backup NIC or any name I want to give. And I'll select my VLAN 2109. As I mentioned earlier, it has DHCP. Hit save. The moment I hit save, OpenShift detected that there is a change to this VM and it gave me a warning that there is a pending change. In order to commit that pending change, I have two options. Either I live migrate the VM or I restart the VM. So migrating the live VM is always an easier option. Yeah, of course, you can reboot it too. So I'll go to the Action tab, Migrate. Oh, there's some existing migration in progress. So migration, and then I'll hit. Oh, looks like when I added the network, it is auto migrating to the VM. So just give it a minute. Okay, it is auto migrated. So in this case, this is one of the newer version. I do not even have to live migrate. It did by itself. It detected the change, live migrated the VM from node 4 to node 1, and my VM is ready. If we look in the network section, look, there's this IP address added. So this is the backup NIC that I added. It had DHCP on the network and it got IP address. Now let's go ahead and verify from the console. I'll go back and hit connect to the console again. Let me clear the screen, IPA, and look at that. I have two IP addresses now. The first one we assigned statically, .242, and then second IP, it got it from DHCP 172.22.9.108. Let's ping the gateway address 172 for that secondary network 9.1. Although it's just layer 2 network, so but this proves that we can ping an external IP from that network too. And this VM still got the external connectivity. So it's all set. We can look at the route table if we want to. And here it is the route table where 4.1 is our default network, and then there's a secondary network attached to it as well. So this concludes our third task of the day, where we attach another network to the VM. So VM is up and running with two different Ethernet adapters or two different networks and IP addresses. Any question, guys?
If you have to do any like advanced routing or anything like that, like you have to do like IP rules or anything like that, is this would you do that through like the network node, the NNCP, or is that like another like the NM? Oh my god, I can't think of the name of the operator. Like where would you make your advanced routing rules if you needed to have advanced routing rules?
That would be part of your NNCP.
NNCP, okay.
Yeah.
Node network configuration policy, and that's brought in through the NM state operator.
Yeah, and that's a thank you. I was trying to figure out. I remember the name of the operator. Yes, NM state operator.
Yep.
So many operators.
Dude, too many.
Hub, right?
Yep.
One central place for all the operators called the hub.
Yeah. So this is where we will define those things.
Okay. Awesome. Nice. There's no questions from the viewers. Yeah, I don't know if you want to carry on. Yeah, I was saying there's no questions from the viewers.
Okay, very good. So then I guess that is end of my demo. And thank you very much, guys. Thanks for attending this part of the demo, and we'll move on to the next section of this presentation.
Awesome. Thanks, Ata.
Yep, thank you.
Cool. Well, then I'll take over, and I can kind of show you what we'll do is migrate a VM from VMware using our migration for virtualization toolkit for virtualization. So let me share my screen, and we can kind of walk through what a actual VM migration would look like.
All right, awesome.
All right, so we're looking at a 418 OpenShift cluster. So Ata was using a 420, so it had a little bit nicer updated interface. So I have a little bit older interface here, just simply because of a slightly older version. But all the same fun functionality here. This cluster is I'm currently logged in as a cluster administrator. We have a number of operators installed. Again, all installed from our operator hub, as we were just conveniently mentioning. The operator that we're going to talk about here specifically that's used for virtualization migration is this migration toolkit for virtualization operator. It's already installed here and provides a number of APIs that we can leverage. And there's already some configurations. When you install this operator, you'll get an additional plugin or view, which actually no, the migration, that you'll have these extra tabs here that we can look at. If we click on overview, this gives us an overview of the toolkit and kind of sees what was installed. One of the providers is going to be connecting to who you want to connect to. As you can see here, we have a few different clusters or providers that are already connected here. Our host clusters, in this particular case, is referencing our current cluster. I have a number of different namespaces being referenced here for our provider plans that are set up, and then my VMware cluster is also set up for a few different users here. So a few different providers. Again, this is all pre-configured, all pointing back to the same VMware for a few different users that are set up as an example on this cluster. This is where you connect, making sure that you connect where you want to migrate your source and your target from. Our source in this case will be VMware, and our target one being our host, and we can take a look at that. Migration plans, we'll take a look at this. This is something we'll walk through as we actually create a migration. This will be the steps that we'll need to do to create that. So there's nothing created here. This is what we'll walk through. One of the other things that's been configured or you can configure is the storage maps for virtualization. So if you have storage maps or want to define what these look like, you have that ability. And then same thing for network maps. So I think that covers kind of the OpenShift, the operator. So we're going to switch over to our vSphere client. So I'm already logged in, and then you can see here, this is my vSphere client for our REA6 iHost, which are sitting behind here. This takes you into your default inventory screen. As I click here, you can see the workloads. In this particular case, it's Red Show. We have a few VMs here that we can see. The database, a hot proxy, and 2 Windows web servers. We're going to migrate 3 of these. We can also see that we have this set up for our networks set up for these, and then same thing, our networks here, and then our database. Networks, and then our data source, I should say. So this is kind of what you would see here, and are currently configured for our VMs. They're currently powered off. We're going to do a cold migration. In order to do, we can also do warm migrations if they are powered on, but you need to make sure that you have read write many. The default migration path is cold migrations, where the VMs are turned off, and they while the migration happens. So if they were running, they'd be turned off. In this case, they were already been turned off worse. So now that we've kind of seen what's in our VMware side, if we look back over on our OpenShift side, again, now with OpenShift Virtualization, we're in the virtualization view here. If we click on, this is the overview, kind of shows us kind of what virtual machines we have. Currently, I don't have any running or any available. If we click on virtual machines, you can kind of see very similar, the trees, the same tree structure that you're very similar that we saw in VMware. Again, as this current user, I'm logged in as user 1, so I only see what my user has access to, where previously I was on admin, so I could see everything. So again, this has RBACs, and then you only get to see what your user has available or permissions to for which projects. In this particular case, we have a project here with just 3 VMs that were already imported. We're going to create a new project to actually import our new VMs to create our new space so that you can see them come over. So to do that, we'll call that we'll call this VM examples user 1.
What happened there?
Cobra.
Oh, I already have that. You can't create one that already exists. So I have that
That's a good
namespace.
error.
That is a good error. You can't. So in this case, we'll then let's see. I don't have access to that. Well, we'll create a different namespace then. Since I don't have access to that one, we'll leave off the S. And there we go. So the next step that we'll need to do is actually create a migration plan. The way we can do that is to go back to our administrative view, go back to our migration section, and then create plans. We can see here, we're now in our example we've run. We all should be able to see the other namespace here that was already previously created. We can use either of these namespaces since there are no VMs in either one of them at this point. And then the next step would actually be to create a plan. Again, to make sure that we have providers here. There we go. MTV user 1. So I was in the wrong namespace for where this needed to be. So this will make sure that we have our namespace is correct. So for creating our plans, we'll use the MTV user 1 namespace, and we have our target namespace created for our plans already. So for our plan name, we can call that, let's say, move web app VMware. Our current project is the one we want, is this project, which is correct, which has our providers and our defined. You can see that here we can choose which one we want. So we're going to go ahead and click our VMware provider. As you can see, it went out and kind of saw which one of our databases. We're going to go ahead and migrate just the 3 that we talked about: the database and the WinWeb 01 and 02 for user 1. Helps to check all 3. So once we have that done, we can click next. Here, our host provider is going to be our target clusters. So our target cluster, which is our host, which is this cluster here. Our current namespace is the MTV user 1, and then this showed our networking for this user space. So our source networks can be our pod networking, and then our storage mappings that were defined that it picked up automatically for our storage classes to be able to map those storages. So we can, once we have all of this set, we can create migration plan. Now the next step here, this plan is going to be invalidating, so that it's going to go through a number of checks here to see, make sure that everything is valid, is working. If everything is okay, this will give us a start. If not, we'll have to then go investigate if our configurations, whether it be storage, networking, something along the way wasn't configured correctly, and we can kind of take a look at see that if there were any issues. So this does take a couple minutes, or should take about 30 seconds to a minute, maybe a little bit longer, depending on the process. But then once this becomes, this should turn into ready so that we can actually start the migration.
Hey, Jared. So when you're running the plan, is it verifying that the storage class exists on both sides, or is it like, okay, cool, here's the storage classes that need to be defined. Let me go make sure that they will be created on the target side, or like what does that flow look like, right? So I see you're going through this and you're making sure that things exist. Like, is anything actually getting created, or is it like, is there anything anticipating to be created, like the networks, the storage classes, any of that stuff?
So it's going to check that the provider can access the APIs. It's checking, so nothing's being created at this point in time, and you can see that the plan's not ready, but it's going out and give all of those things that we gave it, the provider, the APIs. Can it reach that? The storage mapping, is it available in the APIs there? The networking, are all those pieces ready? And then do we have all the correct components needed to actually migrate? So that's all kind of doing the pre-checks essentially.
Okay.
to make sure that you're ready to go, so that if the status if everything's good, you get the start button. If you don't, you'll get an error, and then you'll need to go investigate what. This way, you're not already going all the way down the migration, and then realize this. So this is kind of that pre-check to make sure that what you set up is correct.
Gotcha. So that way, it doesn't take an hour for you to realize you failed.
Correct, right? Because sometimes, depending on the VM and the sizing, right, you get all the way down, and then you realize, oh, it was a network error. We could have fixed that at the beginning. It wasn't even a migration issue, right? So that's what this is trying to prevent.
Okay.
So now that this is ready, I think we can hit the start button. That gives us a little button, pop-up window that we can press start, and that should kick off the plan. We can then click on virtual machines. And we'll see here, now we kind of have an overview of kind of what's happening. We have our three VMs that are actually coming in. And this is our plan details. We can see if we expand these, we get a detail of all the things that are happening. So from our persistent volume claims, we'll see things as things get updated, this will move on us. Again, you can see down here in the pipeline from the initialization, the allocation, disk conversion, the process, and you can see that for each of the three different VMs as you expand these. Again, this will, depending on how long your VMs are, how big your disk size are, will depend on how long this takes. But this is where you can then sit and wait. And if you have any other questions, this is really what you can do to kind of just monitor and make sure that the VMs transfer.
Okay. Yeah. And we did get a question. I'm going to work these backwards because it does kind of work backwards through the demos. But the first question is, when will read write once on Fiber Channel be enabled as a prerequisite for compute live migration? And then also, why is a reboot necessary? Why is the reboot of a virtual machine necessary for HUD adding a network card?
Good questions. I don't have answers off the top of my head for any of those, as a matter of fact. I have to follow up with you on those. That's cool. Yeah, they're just they're good questions though.
Yep. So what I'll do, Hasib, is I'll go back to our Vert team, our product team, unless somebody else here can answer. But I'll go out and try and find out. And if you shoot me an email, Jonny@redhat.com. With the same questions, then yeah, I'll try and respond back to the answers or with the answers. But in the meantime, I'll try and ask in the background and see if I can't find anything.
I'll tackle the question about migration.
Cool.
So adding a NIC, it does work. You can hot plug it. You don't have to reboot, by the way. Migration is required at the bare minimum. Reboot is one of the options to also achieve that hot plug event to happen. But this is just because that's how KVM works under the bottom, right? On the bottom layer, that's the hypervisor that's being used. So re-kicking that network binding that needs to happen. The easiest way, of course, is reboot, but you don't have to reboot. You can live migrate, and that will achieve the same result. And as you've seen in the previous part of the demo that Atta was running, the VM has self-migrated after he's hot plugged the NIC to it. So it is pretty seamless.
So on that self-migration bit, that seems pretty recent, right? Because
yes,
is that like a 421 thing, or is that like a
420? This is where we are. That the first demonstration here that we looked at that Ada was presenting, that was done on 420. I don't know the minor release, right? I'm assuming this is somewhere close to the latest, but it is the 420 release. The long-term support as well, right? That's also important to mention, that the even releases receive longer support than the odd named ones, not named, numbered.
Gotcha. All right, awesome. And so then now we have another question. It says, suppose I need to create partitions for varlog, varlib, varlibpulp, varlibp, GSQL. Hopefully you're not doing satellite, which it sounds like you are. How would you achieve that in OpenShift Vert when there's already a pre-baked custom image?
Yeah, I mean, you can partition at install time, right? You can also add a secondary disk, just like Atta added in his demo. Create arbitrary file systems on them. You like XFS, you like ext4, and then mount them in any file system directory of choice you want, right? This is still Linux under the cover, right? So nothing changes as far as how you partition the drive and how you mount it at a particular file system location.
All right, awesome. And then I'm trying to understand this next part, since the first root disk PVC has already root boot var. Okay, so they're saying basically like how do you modify the partitions without adding a second PVC? But it's just like you said, you can modify it at boot time.
Yeah, you can absolutely do that, right? I mean, it's typically I forgot that we still use LVM, right?
Yep.
Managing volume groups, expanding volume sizes, and then growing the file system. That's all of those tools still apply. There's no magic cloud here, right? This is Linux under the cover. Yeah, awesome. And yes, good luck with Satellite. I've never installed Satellite instead of an OpenShift VM. I'm sure it's doable, but yeah, I saw the pull-up in PGSQL. I can only imagine that that's where you're going. So good luck with that. And then, okay, and Hasid, yeah, go ahead, shoot me an email. It's Jonny@redhat.com, JONNY@redhat. Or you can also email, or I shouldn't say or, and you should attach Sully, SULLY, @redhat.com. And yeah, we'll get your question answered right away. We'll reach out to the product team and find out what the scoop is on that. So what do you know, Jared? What's the max number of migrations that you can do at one point, or what's the max number of virtual machines that you can do in a single migration?
So that really depends, right? I mean, there isn't really a number or a limit per se, right? There's a number of factors that are going to limit or potentially be variables in that question, right? Part of it's going to be your network size. How did you configure your network? So there's a networking cost, right? You can do 10 VMs per plan, so for scaling purposes, but you can do as many plans as you want. Right, so there's really no limit. We've done so just to kind of give you some real world. I've done small VM migrations, 3,000 to 4,000, right? And then that over months or 6 months to a year time. We have larger programs that I'm working on right now that are close to over 100,000, right? Multi-year programs. So again, how much do you do this during a day? Really kind of comes down to how do you do this at scale. There isn't really a limit. How many endpoints or sources, like VM clusters, do you have? How many target clusters also becomes a factor. So there's different ways to scale that out. Just really depends on what your numbers are. Really, I would say like just a typical migration. If you fail to plan to fail, right? Mm-hmm. One of the most important things, and I would not just an OpenShift migration, but really any migration from any technology, any portion of time, is really the planning. If you spend the time and effort to plan, like we use a virtual migration assessment, right? Kind of go through, understand your portfolio, understand your application landscape, build those migration factories or those patterns to be able to scale out, right? That's those important pieces to really get to. If I want to do more than just kind of a handful like we were doing today, automation is going to be the other key. But to answer your question, there really isn't a limit. It's really going to be a number of factors based on your requirements or what you have today in terms of how many, what your network is, what bandwidth that you have available, your number of clusters from both the source and target side, things like that, that actually affect what can I actually do in reality.
Gotcha. Have you seen anybody have you seen any like GitOps approach to doing this where you're trying to roll it out through Argo? Like maybe you're trying to, maybe you say, hey, I want to migrate these 10 clusters or these 10 nodes or virtual machines from this cluster to this cluster. Have you seen that yet?
Absolutely. We have a number of folks, myself, who's built solutions for customers that they absolutely 100% recommending. That's probably the biggest change between what a VMware admin has to come do versus an OpenShift admin is to change into GitOps, and maybe not necessarily at the VM management level, but definitely from the platform and some of the at least the deployments and the foundational infrastructure pieces, and would highly recommend GitOps and infrastructure as code, managing it that way. That will alleviate a lot of the challenges at scale and allow you to actually be able to have repeatable, consistent processes. And there's a lot of functionality within OpenShift, just core platform that can help reduce that overhead and burden.
Yeah, that's awesome.
Now, I just wanted to talk about the migrations for a second, right? Yeah, the sky is the limit, right? Your infrastructure is the limit for real, right? That's the correct statement. But the operator does come with a default pre-configured limit for concurrent migrations, right? It tries to impose some guess about how many your infrastructure can support. But you're welcome to go into the operator settings. That's the migration toolkit for virtualization operator, and even remove that limit, or even change it to some obscure height number, right? The power is in the operator's hands here, operator as in the person, but the operator here is double used as the migration toolkit for virtualization operator.
Gotcha. Yeah, and yeah, no, and that totally makes sense. I feel like I knew that there was a ceiling. I was just trying to remember what the number was, but yeah.
Yeah, I think it's
totally
20 by default, and you can actually see it, Jad, if you down for that, right? You just have to go to administrative view and go to settings.
On the
you go to admin and then just go to migration, and there's settings.
You need me to be in a.
Yeah, go to overview. This is 418.
Yeah.
But
yeah.
see, right hand side, it's actually 9. See that right hand side settings, max concurrent virtual machine migrations.
Yeah, so that's per plan. Max, you're right. So you can do 9 per plan, right? Or concurrently, right? So, but I could do more plans, right? Which gets me over that, right? So, but which then gets me, does my current cluster have enough bandwidth in supporting that? Does my target, right? So, yes, that's kind of where you're at. And again, these are editable configurations that can allow you to go beyond.
Those are good safeguards because you're also hitting the vSphere API, right? So like, if I don't know what network infrastructure you might have sitting in front of vSphere controlling the API request rate, right? You don't want to trigger a DDoS alert saying, hey, your OpenShift is trying to DDoS our vSender, right? In a situation like that. So those are good safeguards to have.
Yeah. And like one way we've done this is, and I've done this before because with certain customers we have, like, instead of 25 40s or 10 25s, right? Some of theirs were 40s and 100 gigs, and these were their kind of what were their network backward and the various, and they had dedicated storage, dedicated migration, right? Which gave us that extra, and then we could actually create additional providers and additional hosts to be able to scale out, right? Which is one way we were able to do that with the customer that had those bandwidths. Again, they had the infrastructure and the bandwidth. Not everybody does.
Absolutely.
So it just kind of depends on what there is a limit, right? In this particular case, right? Like what we said, kind of the tool does put in safe limits so that you can't just overload your systems.
Yeah. Right. All right. Awesome. And so we got a couple of questions. And so the first one is they've seen this user's seen issues when they're migrating Windows machines from one cluster to another. That the Windows machine goes into the blue screen of death. Is that a driver incompatibility? Like what could be the root cause of that blue screen?
Lots of causes. There isn't just one, unfortunately. We've been working to reduce that. I've seen that for as long as I've been doing OpenShift virtual migrations for over the past 2+ years. There is no one single cause. There is usually, it has to do with something, a device driver, a key, something that didn't get replaced or updated correctly. It could be from a number of different occasions. It's one of the most frustrating problems that we've had, and we've been narrowing it down and constantly working with Microsoft to try and fix that every time those and reduce those and create solutions for when we identify those patterns and solutions. But unfortunately, it is just a real thing, and it's not just one cause. And that's just the reality, unfortunately.
Okay, awesome. And then another one is this is going back to the image question a few minutes ago with the partition. So what they're talking about is like, you get like your cloud QCOW2, and it comes with the root partition, or even if you were to pull down like an AMI, it all starts with that root partition, and then you'd have to add an additional disk and then partition that out, or create the LVMs and whatever you want to do. The question is like, how do you start with a QCOW that's got all the partitions in it? And I think the answer would be like an image builder. Back in my day, 100 years ago, we used Packer to do all this, where we would take the QCal and we'd rip it open and we'd create the partitions that we needed. But I think now, I think you can use Image Builder. I'm not exactly sure what the project name is anymore, and hopefully you guys do. But yeah, you can take an Image Builder, you can build in all the partitions, because what they're talking about is like compliance level things. So on one hand, like if you're doing like a STIG, you have to have root, you have to have var, you have to temp, home, all these different partitions. And then for satellite and stuff like that, obviously you need the different, that could always be an additional disk. But do you guys know of anything outside of Image Builder to where you could start with, like a series of those partitions? Because it is not just as easy as just adding them like a normal Linux system, because the way that the QCal is put together. And then the next question, it's in the same vein, is do you know why the VM images that come with the catalog don't use LVM? That's been it's been going on for as long as cloud's been a thing, right? I mean, like that's going back to early days of AWS, where we just had the root disk. It's always just been the QCal with the root. And I used to know the answer to this. I can't remember though.
I'm guessing it's because you have to resize disks, based on like the flavor. It's not flavor, it's the template information. And that piece of technology, I don't know what that is, I forgot. I'm guessing that it doesn't support doing a disk resize with a file system resize, because you have to do both, right? You grow the disk and then you have to expand the file system on it. And there is already a file system in the image, right? So all those things have to happen on the fly when the VM is getting created. So I think it has to do something around that. But a more technical answer, probably get an email to Jonny.
Yeah, it's probably, I think it's a limitation with Cloud Init, if I remember correctly. It's the way.
Exactly. Yeah, it is. It's exactly. It's Cloud Init that's doing that. So if a Cloud Init doesn't know how to handle LVM, you're not going to go anywhere.
But yeah, so pursue eternity. Hit me up in an email. I'm pretty sure it's Image Builder. I'll find the link to the docs and some good examples for you. But yeah, it's either the way that I've done it in the past. It's been like I've either just built a kickstart and I've built an image that way, and then I've just migrated that image into my environment. I use Packer, which is a HashiCorp tool, which is now an IBM tool. So I'm not putting all kinds of craziness out there. But I think Image Builder is the thing that we ship that allows you to build like a custom operating. The other thing that you could do is build a boot C image. And okay, I'm going to take back everything I just said and say that that's probably what you should do. You should probably use boot C, have it output to a QCal, and then start with that as your template, because then you can actually format everything the way that you want to. All right, Jared, I'm sorry. I took over. I didn't mean to.
No, you're good. We're almost there. We've got 2 out of 3 VMs migrated. But that's really, as you can see here, we have all 3 of this completed. And then we can look at the VM here we can start the VM and then show that it's actually working. We still have one more that's still coming over.
So while this thing's migrating, Jared, just a quick question about the blue screen thing. If you have a Windows machine and you migrate it and it blue screens, like what's your recourse?
Basically, remigration is generally without knowing the specifics, because it could be a driver or something that wasn't uninstalled, something that correctly, whether that be guest tools or some other driver that wasn't known. It could a lot of times we have to go through the memory dumps to work with Microsoft to actually analyze what it was. We've seen patterns, but we've seen it's never been just this is just one. The root cause is just one thing, right? It's been a lot of different things, unfortunately. A lot of them come to very similar situations where it's a device where something didn't get installed correctly and didn't have the right key or drivers, or only partially uninstalled. But it could be different. It is not always just the same component, right? It could be from various, and that's really been the challenge. Generally, the pattern to solve it is really to go back, remigrate it, right? Go back, turn it back on, work with the customer, make sure. Generally, it's they need to make sure that we get the VM back up, so we turn it back on in VMware, analyze what we need to do, then figure out a plan, and then remigrate it in the window or timing that was agreed upon.
Okay, gotcha. But there's no like, it's not like they migrated the VM at blue screen and now everything's dead, right? Like there's like their VM still exists over in VMware. Like they would just.
Yeah, and that's the best part about this, right? If you fail in OpenShift, you can immediately go back to VMware. You can turn it back on. It's just a matter of what, the networking or any other changes that needed to be made, if any. And in this case, ours didn't. We could just simply turn off the database in VMware, turn ours back on, and go back to VMware. Very simple.
Awesome.
And then you can kind of see here, if we open up the console, we should be able to get to the machine. We see it starting back up. If we go to the, we can even, yep, and we can see here, it's starting to be good.
So what would you say are some of the gotchas that you see?
The biggest gotchas I would tell you would be really kind of the failure patterns in the migration plans, not getting those right, not having the network configurations. There's a lot of pre and post requirements that can be done. So there's hooks that you can use that get into more advanced use cases of your VMs, right? We have a very kind of simple use case, so dependencies, right? Really kind of comes back down to that planning. If you're migrating just one, is it really one out of the one database or one VM, or do you need to migrate all of those, right? So it kind of gets down to making sure that that you've done the planning right, you have those grouped appropriately. In terms of individual migrations, usually that depends on how you've grouped those, right? RHEL and like typical RHEL clones and Linux are generally fairly easy. Windows are about a medium because again, you run into kind of different device driver issues, things like that. It kind of just depends on overall of where you've kind of gotten to when it comes to the kind of the VMs. Databases are one of the more challenging ones. Again, depending on if you need failovers. So the gotchas will be in a lot of different areas depending on kind of the different types of VMs and how you're migrating them. Again, warm versus cold. So there's a lot of variations or a lot of different ways. But so there's gotchas in a lot of ways, but if you've planned and you've kind of built in, one of the key things I would also tell you is when they fail, bringing those back and building out a pre-flight checks and continuously adding to those as you figure out what fails, add that to your pre-flight so you're no longer hitting those failures. Again, that's a way to kind of be able to stop hitting those same errors and issues over and over again. But yeah, those are some of the major gotchas of migrations.
So basically, you're saying don't wing it. That's what you're saying. If you have a large migration, winging it's probably not the right idea.
Correct. Do not wing it. Those are the ones that do not go as planned and in budget on time. The bigger it is, the harder it is. But yes, don't wing it.
All right, awesome. All right, cool. Well, I know we're kind of coming up on the top of the hour here. I guess we're over time now, but I think we've seen that, 2 out of 3 have migrated. Obviously, it takes time for these things to migrate and stuff like that. So we could either sit around and wait for all this to happen, but I don't feel the need. I do want to say before we go, if there's any closing remarks that you guys would like to put out, let's go ahead and do that while we start to wrap up. And for the audience, if there's any questions that you have, now's the time to ask them before we start shutting down.
The only other thing I would tell you is if you're interested in learning more, we have a whole bunch of learning that you can go to that we can put out is for that not only docs, videos, learning arcades that can go through this. If you're interested in the OpenShift experience that we saw, you can definitely sign up for this as well. So definitely, if you're looking to gain more, Jonny, I'll make sure you have those links that we can share out. But then, yeah, definitely, there's a lot more to learn, and let us know if you have questions.
Awesome. Cool. All right. Well, to Jonathan and Jared and Machi and Atta, I know Atta's out of here, but thank you very much for coming on to the stream. We really appreciate it. And let me see if I can get rid of this view because it's killing me. Let's see. All right, get rid of this. All right, here we go. Here we go. But yeah, so oh no, there it is. I'm sorry. I thought you left for some reason.
No.
But no, thanks for joining. I really do appreciate it. It's been an awesome stream, and it's like we've been talking about the virtualization stuff or the migration stuff for a long time now. So to see it kind of like it's the maturity of it, OpenShift Virtualization's maturity, and then having all these tools kind of come together. Like I feel it feels like our OpenShift, like, you know, whatever it is, like machine is all starting to like really all the cogs are starting to work together, and it's pretty cool. Yeah, and so at intended Eve, I will put it in the show notes. I'll put the links to the arcades and stuff like that once I get them in the show notes, so that you can have them. But yeah, so again, this is part one of this migrating your OpenShift or migrating your VMware workloads into OpenShift virtualization. Part two is next week. We have a few other streams coming up. Oh, actually, hang on, let me copy here. And I'm sorry, you guys have to deal with me and my sound effects. But yeah, so we'll have part two coming up, and then we've got a couple of guests lined up. We're trying to get back to a more technical stream. So things like what we've seen today, where we're actually doing demos. You know, we'll kick it off with a couple of slides, but really trying to dive into the technology again. So if you have any requests, if there's anything that you want to see, hit Sully and myself up, and we will do our best to get them on. But Maji, Jonathan, Jared, Atta, really do appreciate your guys' time. I know it's not easy coming on these things and you know, putting yourself out there and answering questions, and then having somebody in the first comment try and give you a Russian roulette bash script to freaking throw. So, you know, people are crazy. It's awesome. But yeah, I hope you guys have a great one. I really do appreciate your time, and yeah, catch you next time.
Thank you.
Cheers.